Hello everyone, hope you are doing well. So today I'm recording a session of one of the most important topic of Java in terms of interview perspective, okay? And 90% you will get the question from that particular topic, right? What is a map interface? So some question that comes with map interface that we are going to understand with this particular session. First, what is a map interface and how does it differ from the other data structure? First question. Second question, internal working of HashMap. Third question, what is the default size and capacity of internal HashMap? Okay, how to increase the size of internal HashMap? What will happen if key is null? What happen in the Java HashMap if their number of entries nodes in a single bucket exceed 8? What does that? Okay, we'll look on in that. In HashMap, if the same key is inserted multiple times with different values, then what will be the output when you use the get method? What is hash collision and how does it remove from the Java 8 onwards? So these are the very common and very popular questions, and I can say 100% guys, maximum time that question will come during the interview. If you are giving interview of 5 years of experience, 10 years of experience, right, as a fresher or any type of job you are applying, right, definitely you will get these questions. Okay, so let's start with this. What is a map interface and how does it differ from the other data structures? Okay, so map is a one kind of interface in Java, right, which store the data into key value pair, right? It represents the collection of key value pairs, so it will store data into key value pair. We'll look some example as well. Map is a type of collection but not a part of collection. What does it mean here? In Java we have one collection topic, so collection is a one interface actually. So map is not a child of collection. So that's why I'm typing here. Map is a type of collection, not a part of collection. Part means it is not a child of collection directly, but it is behave like a collection because collection itself is saying like storing multiple values at the same time, right? Multiple values at the same time. That's why it is a type of collection but not a part of collection because it is not directly child from the collection. Okay, where each key is unique in this map. Whenever we are storing, so key will be unique, key cannot be duplicated, and each key maps to exactly one values, right? Corresponding one key, we will having a corresponding one value as well. That is called complete entry, right? So one more word you will get it like entry. So entry is nothing like a combination of key and value pair. Combination of key and value pair. Okay, so whenever you have a like key and value pair both, and if you want to merge in a single things, that is called entry only, right? It is similar to a dictionary or hash table in other programming language. Even Java also it is that dictionary and hash table, but it is legacy one. Okay, legacy means it is added on the 1.1 onwards, JDK 1.1 onwards, right? That's why they are called legacy one. Okay, so key characteristics of the map: you can store, retrieve, update and delete values using the key, right? Using the key. Duplicate key are not allowed, right? Adding a key that already exists replaces the values. So if you add duplicate keys, that time it will remove that previous value and it will override the updated one. And duplicate value are not allowed, right? Duplicate value are not allowed. A map does not maintain insertion order by default, right? Insertion order means what? That we are going to also understand. Insertion order means the order I am adding the element, right? The same order we will not get the element, right? So there is some kind of property characteristics of the map interface. Map will not allow multiple same null key, right? It will having only unique null key, not duplicate, right? And it does not maintain the insertion order, right? So these are the some kind of property of the map interface, right? Now let's understand with one example how does it look like that. So whenever you want to create, let me create one example here. So that should be like test 1. And here I am passing a main method and putting a one map interface, using a one map interface. So here I am passing it as a keys as a string and value is like suppose integer. Okay, it could be any. So here m equal to new HashMap. Okay, and I'm adding some value on it, right? M dot put, suppose M dot put, I'm putting here suppose first ln, okay, second I'm putting right M dot put, here I'm putting like black, okay, and next I'm putting okay, it is taking key value pair, right? So here we have to pass value as well corresponding, that I'm passing here 10, here I'm passing here like suppose 20, okay, here I'm passing suppose, let's provide some more key, okay, it could be like suppose James, okay, it could be like suppose black, let me pass at bottom, and here I will pass like suppose Max, okay. So I'm adding here some entries, and let me put this in sysout as well, system.out.println, and I'm passing here suppose M, okay. So what does it happen here? Let me run this. So this time you can see that I'm getting James first, but I'm adding James in third, right? Max at second, Max second, fine, black third, right? But black I'm adding at the fourth. So that is the meaning of insertion order. The order I'm adding the element, right? I'm not getting the same order. That's why it is saying that insertion order is not maintained by the map interface, right? And let me put this twice with the same key with different values. This time I have two entries by the same name like black. Let's see what does it do on this case. So this time it will give me only single black, which is a 50. That means 20 has overdone with the 50. So if you are having a duplicate key, so first one is a key. Here we are making it generic. So key will be type of a string. Whenever you are working on map, right, you have to keep key is a specific type, is strings, okay, and value also one specific type. So here I am saying that here key will be string and value will be integer, right? So that way we are adding the element on it, and that way we can get the element, right? So these are the some characteristics, like insertion order are not preserved, okay, it could be any order, okay, duplicates are not allowed, and right, one more thing that will come here, which could be it will store always in the key value pairs, which is not stored by the other data structures. Other data structures store data elements into a sequential order. That means indexing is managing automatically. Here this is indexing actually. So here we are getting directly that value, right? We have one more way. If you want to get a specific value, then how we can get it? So that time we have to use what? We have to use get method. So we have one get method as well, which will take key as a parameter, right? Suppose I want to get the value of Max, right? So Max is a one key actually here. Max is a one key, and I will get the value of it. So I can write m.get max. So what does it do here? It will give me a value of max, which could be 20. So you can see I will get 20 here, right? So this way it will work map, right? Now let's come to the next question. First question, what is a map interface and how does it differ from the data structure that I've covered it? Now we will understand internal working of map, HashMap. How does it work internally, right? So whenever you're talking about internal working of HashMap, right, you have to keep in your mind two things. You have to keep in your mind two things. What is the two things? If you do not know, please watch the object class tutorial. I have already recorded it. You should know about the use of equals and hashCode method. That does play a very important role. hashCode method. If someone will ask you about internal working of map method, right? What is the meaning of it equals and hashCode method? Let's understand that. Okay. So here I already created one class like key class. So in the key class I am adding a one object like name only, strings, one name only, okay, and having a some constructor, no parameterize, no parameter, let me keep it on top, okay, and parameterize, and having a some getter setters, okay, let me make it setter as well here, generate setter only, okay, fine, it's not required. So it will having a getter setters, okay, kind of that, and let me remove this hashCode and equals method. Let me remove this hashCode and equals method now. Yeah, setter already there here actually. Okay, so this time I created one key class which is having a name variable, which is having a some constructors, no parameterize and one parameter, and having a getter setter method, and having a one toString method as well. Okay, now what I will do here, let's go here. Now inside that I am adding here, I'm taking a one map, but here the key will be the key type. So key is a custom class. It's not like the key. Okay, it is a custom class, and I'm adding here some values. So what I'm doing here, let's say I'm using here whence twice. Let me add one more entry here. m.put, and I'm putting here like new key. And here I'm putting suppose whence twice and with different values, like suppose 30. Okay, so what will happen here? In this scenario, I'm adding whence twice. As we know, right, map does not allow duplicate. So here key are unique. Whence, name is same only, right? Right? Let's see what will happen here. If I will run this code, you can see here it is giving me a null. Okay, I have removed this hashword equals, right? So that will give me a null. So let me remove this one and let me run this now. Oh, I think I have to pass this out, and I have to pass here this m only, not result. Okay. So this time you can see that I am getting whence. I am getting both whence. One is with 10, one is with 30, which is not a nature of map actually, because I created a custom class, and previous scenario it was a string class. A string class was predefined class. So in the string class, the two method which I told you, right, equals and hashCode, is already overridden. But in the key class, I did not override that, right? So one thing you have to understand, that whenever you are adding any objects into a map, you have to be careful about it. This class has implemented hashCode or equals method or not. If it is implemented, then it will work fine. If it is not implemented, it will break the rule of map, right? So what we have to do, first we have to go to the key class, and we have to understand that does this class implemented hashCode or equals or not. So right now it is not implemented, is not overridden, because I have removed it, because I want to tell you how does it work without overriding hashCode and equals method. So if you will not override hashCode equals method, right, it will not allow uniqueness. It will take duplicate keys, which is not a rule of map interface. So what I will do, I will go under this key here, and what happen, I will generate and I will add some hashCode and equals method on it, right? So hashCode equals method is overdone now. Now let's see if I will run it, right? See what will happen. This time it is giving only single whence to me, which is updated value like 30. It is not giving me twice, because here it is working with equality, because it has overridden the hashCode and equals method. Now how does it work? Please understand, right? How does it work? So whenever we are calling the map.put method, right? Whenever we are calling the map.put method, then it will directly call the hashCode method. So for every key, whichever we are adding the key here, right? For that key, it will generate a one hashCode. Okay, it will generate a one hashCode. Let me write down here. It will generate a one hashCode. Hashcode it will generate for every key. For every key, right? JVM generate a hashcode. So it will generate hashcode on the basis of on the basis of on the basis of key whichever we are adding, right? So for whence it will generate a one hashcode. For whence it will generate a one hashcode, right? So for this whence it will generate a one hashcode, right? So how does it generate the hashcode? It will call internally hashcode method, right? If you will override hashcode method, that time it will call your on class method, otherwise it will call object class method. So in the key class we have overridden the hashcode method. So you can see here it is directly giving me objects.hashcode with a specific name. So whatever name we have, right, like name is that I took, right, on the global variable, for that particular name it will generate a one hashcode. The same bit will return to us, right? So please understand that whenever we are adding any key on it, whenever we are adding any key into the put method, right, directly it will call the hashcode method. So here it will call the hashcode method. So that time suppose it is generating the hashcode like suppose 118. or it could be any hash code, right? 116 or 118. I'm just assuming it could be any, right? So here it is just giving one hash code, and if you are adding some new entry on it, right, that time again it will generate a one hash code. So we know that here key are unique. So first it will generate the one hash code, and for second also it will generate a one hash code which is like a same only, So if we have a same hash code, right, then what happen, right? It will directly call the equals method. When it will call the equals method, if hash code are the same, if hash code are not same, then it will not call the equals method. So first, whenever we are adding the key on it, right, it will directly go to the key class and it will call the hash code method. Hash code will generate one numeric value for every key. For every key it will generate a numeric key. Then if keys are unique, it will call the equals method. Then equals method will compare it, right? Then equals method will compare it. What it will say that the previous values and the existing value both are the same. Then it will not add it. It will say that okay, it is not allowing on it because it is already exist, and it will override with the updated one. So that's why you can see here, right, it is giving me a 30 instead of 10 because that 10 one will override with the 31. So that way it will work. So you have to understand that for every key, right, first it will call the hash code method, right? And when it is called the equals method, if the, let me write down here, okay, equals method only will call equals method will only call if hash code are same. If hash code are same, and hash code will call for every key, right? So for equals, it will call only when the key are, right? It will call only if the hash code are the same, then only it will call the equals method. But hash code will call for every key, right? So for this, hash code will call how many times? 4 times. But equal will call only 1 times because here it is a unique only. If I will not keep this line right here, that time equals will never ever call. So equals is only will come here in a picture if it will say okay, 2 hash code are the same. If 2 hash code are the same, then please compare them and then give me that latest one, not like the oldest one. So it will give me the latest one with the updated key only, right? So that is the internal behavior of the HashMap. Please understand, okay? HashMap work, this technique is called hashing also. So sometime you may get to know that what is hashing in map interface. So what is hashing? Hashing is a technique which is a combination of hash code and equals method, right? So for every put method, it will call the hash code first and it will check that key are the same or not. Sorry, hash code are same or not. If hash code are the same, it will call the equals method. On the basis of that only, it will manage the uniqueness. Because here hash code and equals, any one of them will not be work. Let's say if I'm using the hash code, right, and if I'm not overriding the equals method, if you will not override the equals method, then it will call the object class equal method, and we know that object class equals method does the reference comparison, not like the content comparison, and here we have to do the content comparison actually. If you are not aware about that object class and all, please watch the object class first, then only you can watch it, then only you will understand completely internal working of map interface, right? So map interface will work like that way. First it will call hash code method, then it will call the equals method, right? So equals method does compare that and it will check if 2 hash code are the same, fine. It will not allow that because equals are come in a picture, right? And if the hash code are different, then equals will not be called, right? That way. Next question we have, okay, what is the map? Internal working of HashMap. What is the default size and capacity of the internal HashMap, right? What is the default capacity and size of the internal HashMap? So we know that the default capacity of the map is 16 and the default load factor is a 0.75 and default size is 0, right? That means entry count, right? So here default sizes means entry count, capacity means how much it will store. So that way it does manage the size. This means the HashMap will resize or rehash when it reaches to the 16 multiplied 0.75, that means 12 entries. So the default HashMap which we have, right, it will calculate the total entries, how many entry will be allowed on it, that will multiply with the capacity with the load factor. So capacity with the load factor will multiply, that could be 12. That means it will say it can be allow only the 12 entries, right? That means if you will insert the 13th item on it, right, it's automatically resized to the 32 bucket, right? So 32, it will resize automatically and it will make it 32 on it, right? So you can say the double of it, that means 16 multiplied 2, that could be 32, right? We can set the initial capacity explicitly with the load factor as well. If you want to change the initial capacity, default capacity of it, right, we can do that as well, and we can change the load factor as well. So how we can do that? At the time of creating the object, right, we can pass as an argument here what could be the capacity and what could be the load factor you want. So here you can say that I am changing that default load factor. So default is the 0.75, right? But if you want to change that default load factor, that also we can do it. Here we are passing f because it will be in the form of float only. So 64, 0.5, right? So if required, you can change the capacity, right? And you can change the load factor as well, right? So that is a clear, right? What is the default size and capacity of the internal HashMap, right? So that is a 16, right? And if you want to change, we can change as well. How to increase the size of internal HashMap, that I told you, we can pass in an argument with a specific size and with a specific load factor. We can change that as well, right? What will happen if null key is there? One of the most important question here, right? What will happen if key is null, right? So we know that HashMap does allow a single null key. HashMap does allow single null key, right? Let's say here I am passing null. We can pass, right? Let me here passing like null. So here I am passing 2 null. So here the question is that what will happen if we will pass null as a key? What will happen if we pass null as a key? So that time key will be unique, key cannot be duplicated. So what could be the result here? So that time if I will run this, right, it will give me null with the 30. It will give me null with the 30. So how does it store in a bucket actually? How does it store in a bucket? How does it perform the operation? So let me explain that whenever we are going to null, okay, and how does it calculate that index of it. Yeah, one more important part here. If we are having a hashCode, right, and what is the bucket size, how does it work, that is also part of internal HashMap only, right? So that also let me show you that once. Like for example here, it is a bucket size. So bucket will be 0 to 15, right? Here I am adding some entries, Samuel, Vance and Vivian, right? That way we are adding. So if we are adding some entries, right, like Samuel I am adding Vance. So for Samuel, suppose it generated 115 hashCode. Once it is generated 118 hashCode. For Vivian, it will generate 118 hashCode. Okay. So let's say if it is a 115 hashCode, but 115 is not indexed into a bucket. So how does it calculate this capacity actually? So what happen, right? It will calculate the this index by using one formula. The formula is that, what is the formula here? The formula is that it will calculate by using the hashCode mod capacity. So capacity here we have like 16. So you can say here it will calculate the hashCode of 115 mod 16. If you will get it right, mod will give a reminder, right? So that time I will get reminder is like 3. You can calculate. So if I will see 115 mod 16, right, till 1112 it will divide completely. So that will be 3 remainder. So that's why I can say it will be 3 remainder. So that means 3 will be the bucket size here. So at 3 it will store, at 6 it will store, and according to that it will store, right? So how does it store this? How does it find that bucket? Here it will find the bucket size bucket according to this formula only. So here it is calculating hashCode mod, the total complete capacity of this particular bucket. So this is a bucket only, and index will find accordingly, right? So here index will be 3 like that. But if I will add null here, then what will happen, right? Let's say if I am adding here null. Just give me a minute. Why it is not working? Let's say if I am giving here null. So it will calculate null, right? So if you will pass here null mod 16, right? That time what will happen? So that time it does give a null pointer exception, but that is the default nature of it. Let me show you that as well. So when you will add key equal to null, right? So that time it does give a null values, so it will give a null pointer exception. But that internal mapping, the internal working is that if it is saying key equal to null, right, that time it is giving give a 0 to this particular hash code, right? That means bucket index calculation, how does it happen? The hash value 0 for null, 0 for null, it is automatically consider that null means it is considered like 0 only. It use calculate the index of the bucket. So index will be calculated hash mod table dot length, right? So length I told it could be 16 only. So that null key always goes to the bucket index 0. So it is always going to store into bucket index 0. In insertion phase, it check if any entries already exist at the bucket index 0. If it is does, it check if key double equal to null. So find the matching entry and update it particular this. Otherwise, it create a new entry at index 0. Right? If you want to retrieve it, we can retrieve by using the map.getNull. So if you retrieve, right, that time this uses the same logic. If hash equal to 0, index equal to 0, scan bucket 0, return values where the key equal to null. So always remember that whenever we are putting the key equal to null, that means it is by default assigned. Otherwise, what happen, right? It will give null pointer exception. To avoid null pointer exception, JVM decided that instead of giving the null pointer exception, we are giving the 0 value of it, because here we can add one null key. We can add one null key. So whenever you are giving null key, right, that time it will give me 0, and according to the 0, right? So you can see here, right? You can see here, if it is 0, right? 0 mod 16. What could be result? That could be 0 only. So if you are having a null key, right, that is one of the popular and one of the most important question. If you have a null key, then what will happen? So if you have a null key, by default JVM will give a 0 index for that, right, and accordingly that value will store into the first index itself, first index of the bucket itself, right? And whenever it will retrieve, it will check with the null and compare with all the things, and it will retrieve with the null values, right? So that is one of the question. What will happen if key is null? So if key is null, it will always store into a first place, right? It will store into a first index, right? That is a use when we add the null key. Now next question, what happen if the Java HashMap, if the number of entries node in a single bucket exceed 8? That is one of the most important question that has part of the kind of hash collision. So what I will do here, I will create one example. So I am sharing one example here. With the help of that, I want to explain that. So first of all, you have to understand what is the meaning of this question. The question that what happen if the Java HashMap, if the number of entries means node in a single bucket exceed 8. So actually HashMap does store data in the form of linked list. What does it mean? What does it mean? So let me show you that here. Let me show you that here. Like for example here, you can see that here I am adding some element. So here it is having a something. First we are having a hash code, and we are having a some name, and we are having a some 30, and we are having a some null. So what is the 30 here? 30 is a kind of value of it. So it is having a three things, 115, Samuel and null. So how does it store internally? Let me show you that as well. Okay, let me show you that as well. So whenever we are putting, suppose we are saying, okay, please insert a key value pair into a HashMap using the put method, then following internal step does follow. So map.put new key whence 20. How does it do? So it calculate the hash code for the key, and it will be generate one hash code, right? And calculate the index by using the index method, it will be 6, right? And create a node as. So here we having a one node. So what does happen? First it is having a like hash code, which is a hash, and it is having a one node as well. So node will having a like what? Node will having a two things. One is the address, and second one is a value. Node will having a two things, address and values. So here you have to understand this node. I am talking about the linked list perspective. So in linked list we have a node, right? So node is nothing like a combination of two things, right? Let me open the pen. That also let me explain you what is a node. How does it store? It is going too long, guys, but definitely that will help you a lot. If you will complete this, watch this complete video, right? You will get a lot answers of the every question that comes with the map, right? So here we have a like suppose node. What is a node? That I am going to explain actually. So node is something which is having a two things. So that is depend on the singly linked list or doubly linked list like that. It is a one kind of node which is having a two thing. One is having a data, and second one is having an address. One is having a data, and second one is having a like address, right? So data will having a data. Like for example here I am adding some data. So here it is storing suppose like 20, right? And here it could be null, or it could be having some address as well. Address could having some null, or it could having some value as well, right? So that how does it store? This is stored in the form of node format. Value does store always into a node format, right? So here place this object at 6, and if no other objects presented there, right? So insertion second key value be same, it will do the same for that, right? So it will insert the element like that way only. So whenever we are adding the element, right, this element will be added in the form of node only. So node will having two things, key and value. Sorry, node is having two things, which is the value and address, right? So what is the question that we are discussing? The question was, what does happen if that node in a single bucket exceed 8? Here it is talking about like this only. Suppose we have one bucket index like 6. In the same index, multiple entries are increased. Like for example, how does it possible? First of all, how it is possible? So you can see here in the single index, every index, it will store that key and value. It will store the values, right? And key, it will calculate according to the hashcode only. Sometime it is happening, my value are different. Sorry, my keys are different. My keys like your Vance and Vivian, these are the two different key. But what happened, right? For both that key, it is generating a single hashcode. Okay, so it may be a possibility you may have a multiple hashcode, sorry, multiple keys, different keys, but that key will generate a same hashcode. So that question is asking, if we have a single node, if we have a that we have to understand. So that only it is saying that. So from the Java 8 onward, actually from before the Java 8, right, whenever it is having like 8 entry or more than 8, right, in a single index, that time it is called like hash collision, because it was using that linked list structure, which I told you, right, node, it is storing linked list structure. But from the Java 8 onwards, this linked list has converted into a red black tree, right? It is converted into a red black tree. So what is happening here? If it is having a, like I designed one example here, so I use the one this example which is having a like key. So I created a one key with same hash code, and here I have written the hash code, and here I am written the same hash code like 42. For all the entries I am writing the same hash code. If it is the same hash code, and you can see that key will be different, but hash code are the same for them. So here in this example you can see here I am adding this as a key. So key will be key I will be what, 1 2 3 4 5 something. So that key will be different here, but the key, you know that whenever we are adding the key, it will call the hashcode method, because it is a custom implementation of mine only, right? That's why I have written the same hashcode. Right? So I want to explain you, right, if it is a single index of the bucket having a more than 8 entries, right, then what will happen? So then what happen, right? It will use a one terms called treeification. What is that? Treeification is the one terms actually that you have to understand that. So that you have to explain to the interviewer, whenever we are adding, it is exceeding the more than 8 nodes in a single bucket, right? Sorry, in a single index of the bucket, then it is using treeification, and treeification is giving a faster access to us, and it is converting a one complexity. So treeification having a one terms, and it is having giving a faster access to us. How does it give a faster access? Let me show you that. I think it should be in the PPT only. Yeah, so see here. So when multiple keys map to the same bucket, collision, right? It is a collisions. In HashMap, initially store these entries in the linked list form. If the number of entries in a bucket exceed a certain threshold, typically 8, HashMap switches from the using linked list to a balanced tree, that is a red black tree. This improved the lookup performance from O of n. O of n was the Java 1.7 onwards, and that is the worst case with the linked list, and has converted to the O of log n using the tree. So O of n is converted into O of log of n actually, right? O of n has converted into O of log of n when we are inserted more than 8 node in a single particular index of the bucket, right? So that is called treeification. So treeification is a one terms which is used to improve the performance of the particular node, or to improve the performance of this particular application. So that is the answer of this particular question, right? So what is the question here? The question was, What happen if the Java HashMap in the number of entries node in a single bucket exceed 8? So if it is exceeding 8, right, from the Java 8 onwards I'm talking. Before Java 8 onwards it was a hash collision. From the Java 8 onwards it is converted that linked list to the balance tree, which is black tree, right, and it is using a one terms called treeification. So treeification is improving the performance and it is converting that the complexity, right, from O of n to O of log of m. So that is the main use of this answer of this particular question, right? What happen if the Java HashMap, if the number of entries node in a single bucket exceeding the 8, right? Next question, in a HashMap, if the same key is inserted multiple times with the different values, right? In the HashMap, if the same key inserted multiple times with the different values, what will be the output when you use the get key method, right? So that time what happen, right? It will give the updated one only. So that is the answer of it, right? Because same key inserted multiple times in a different values. Value are different, same key is there, right? So what is the answer of it? It will give me the updated one only, not with the previous one, right? That we have already seen it. What is hash collision and how does it remove from the Java 8 onwards? So hash collision is nothing in a single particular index, right? If we are having like multiple entries in a single index, right? Like for example, this scenario. Here we have a like in index 6 and having a like suppose 2 entry. It may be possibility in a single index may have a like 10, 12, 13 like that, right? That time it is comes under the hash collision, right? So to avoid that, in Java 8 onwards, they have changes that linked list to the black tree, which is the balance tree, and it is using a treeification terms. Please remember that treeification. So treeification is the one terms which is used to improve the performance of our application. So here what happened, right? In this example, I added a 12 entries, right? I added the 12 entries with a single index of the bucket. How I'm saying that? Because I'm returning the same hash code for all the particular key. So if the same hash code, that means it is storing into a single hash code, a single index only, right? Because on the basis of hash code only it will calculate the index, right? And then we are getting it. So that time it is retrieve the values and to check the performance theoretically faster by using the treeification. So these are the complete questions of that HashMap related, right? You can watch it completely and answer and crack your interview. Thanks for watching guys. Take care. Bye-bye.